Good morning, students. We are still on equilibrium as a topic. Remember, we started this equilibrium yesterday, so we are still on it. We go to video number 15. Yesterday, I gave the introductory part of the topic of equilibrium. Today, I'm going to solve examples on that equilibrium. So, the first example I will solve is an equilibrium is this. I read the question. A particle of mass 5 kg is supported by two light inelastic strings inclined at angles 30 degree and 45 degree respectively to the horizontal. If the system is in equilibrium, calculate the tension in each string. Calculate the tension in each string. This is the question. So, now what are we looking for? We are looking for the tensions in each of the two strings that is holding the particle. So, we solve this question by first of all drawing the first diagram. We draw the first diagram. Now we are told that we have a particle. This is a particle. Let me just use this dot to represent. Let me model it as a particle. Let that dot be the particle. So now the mass of this particle is 5 kg. So because of the mass, the weight will be acting vertically downwards. That is the weight of that particle, W, which is equals to W is equals to mg. So this particle is being supported by two strings, two strings attached somewhere. By two strings. So this string is being fixed. The end of the two strings are fixed somewhere, maybe on the ceiling or on the wall. Then while the two ends of the strings are attached to the particle, then the weight acting vertically downward. We are told that these strings make angle of make angle of 30 degree, 30 degree and 45 degree to this horizontal, according to the question. Now, let the tension in the two strings, let the tension be T1 and T2. T1 and T2. Let the tension in the two strings be T1 and T2. Let the tension be T1 and T2. So that is the diagram. Now we have to calculate this tension. We have to calculate this tension. So, calculate the tension in each string. Now we are told that the system is at equilibrium. If the system is at equilibrium, then we apply the condition for equilibrium. Now, since this system of forces is at equilibrium, then summation f of x is equal to 0, and summation x of y will also be equal to 0. These are the conditions that we're going to apply in solving these questions. Then what is summation x of x? Resolving the forces, resolving the forces horizontally. I have now I will start with T2 because the horizontal component of this tension T2 in the positive direction of the x-axis is going to be T2 cos 45 degrees. Then the next force is T1. Resolving this T1 horizontally because it's toward the negative direction of the x-axis, that will be minus T1 cos 30 degrees. There is no other force acting in the horizontal direction, so that is equal to 0. That is equal to 0. Now, call this equation 1. Resolving the forces vertically. I have this one is the vertical component of T1 will be positive because it's in the upward direction. So that will be T1 sine 30 degrees. This is also positive plus T2 sine 45 equals to 0 because it is at equilibrium. So this is equation sorry. Not equal to 0, sorry. Not equal to 0. There's another one. There's another force acting vertically downward. Because there is nothing vertically. There's another force acting vertically. So, and which is the weight. So T1 is upward, the horizontal component of T1 is upward, the vertical component of T1 is upward, the vertical component of T2 is also upward in the positive direction of the y-axis. Then we have another force acting downward, which is the weight. So if the upward direction towards the positive direction of y-axis is taken to be positive, then the negative direction of y-axis is taken to be, the y-axis downward is negative. So that is minus w is equals to 0. But w is mg. So this means that T1 sine 30 degrees plus T2 sine 45 degrees is equals to mg. Is equals to w first. Is equals to w. So I can clean this means that T1 sine 30 degrees plus T2 sine 45 degrees is equals to mg. Is equals to mg. M is 5. G is 10. So that is 5 times 10. Yes, I think so. Yes. So it means T1 times sine 30 is 0.5 plus T2 times 0.7071, I think.
Yes.
Is equals to 50. So this means that 0.5 T1 plus 0.7071 T2 is equals to 50. It's equals to 50. It's equals to 50. So I can make T1 T1 is subject of the formula here. So 0.5 T1 equals to 50 minus 0.7071. Yes, T2. T2. I can call this one, yes, I can call this one equation 2. Now, from equation 1, I have T2 cos 45 degrees minus T1 cos 30 degrees is equals to 0. So this is what I have. Then, so this means that T1 cos, okay, let me go so that you understand. T2 times cos 45 is 0.7071 minus T1 cos 30 0.866 equals to 0. Now, so this means that T2 cos, this is 0.7071 T2 is equals to, take this across, is equals to 0.866 T1. Therefore, T1 is equals to 0.7071 over 0.866. Yes, T2. So, now, complete the other side, please. T2. From equation 2, I can have from equation 2, T1 is equals to 50 minus 0.7071 T2. Everything over 0.5. So this means that, so what have I done? T1 is equals to that. Yes.
That's 100 minus. Minus 1.414.
No, I want to. This means that T1 is equals to 50. I want to do step by step so that you will understand. 50 minus 0.7071 over this 0.5 is half. 0.5 is same as half.
T2.
That is T2. So now, these two will move up. So I can now have, therefore, T1 is equals to 2 into 50 minus 0.7071 T2. I think it's okay, right?
Yes.
Yes, okay, right? So then T1 is equals to 100 minus
1.4142.
1.4142.
4142.
Yes. T2. So this is still my equation 2. Where's my equation 1?
This
Okay,
one.
I have already cleared it.
These two can be equated. The
Yes.
last one here.
For which one did I refer to as equation 1? Okay, I've already cleared it. Okay, this is from equation 1.
That one is still equation
This
1.
is still equation 1. So equating 1 and 2. T1 is equal to this, T1 is equal to this. Equating 1 and 2 gives
0.7071 over
0.7071 T2 go?
yes,
T2
over 0.866
over 0.866
equal
is
to
equals to
100
minus 1.4142 T2. So I can cross multiply.
yes,
Can multiply 12 by 0.866.
yes,
So I have 0.7071 T2 is equals to 0.866 into 100 minus 1.4142 T2. Is enough?
yes,
Then, therefore, T2 now, T2 is equal to 0.866 over 0.7071 into, yes, something like that, equal to T2. So that I can divide this by this.
okay,
So that T2, that
okay,
this by this.
0.866
I think it's not like that.
divided by
0.771.
0.7071. Okay, the answer is 1.2247.
1.2247 into 100. I think it's correct like this.
Yes,
100 minus 1.4142 T2. So I can now multiply by this. T2, this by this. That would be 122 points, no?
yes, 47.
Equals to 122.47. Then minus this by this. See, but
Yes,
1.2247.
1.732.
1.732. Down.
Yes,
T2, isn't it?
yes,
T2. Now I can now collect items. I can now bring this side. So I have T2 plus
1.73.
1.73 to T2 is equals to 122.47.
47.
I hope I'm not blocking the big one.
No.
From there, okay, let me reduce that. T2 plus 1.732 T2 equals to
122.47.
122.47.
Yes.
Then I can factorize.
No,
T2,
2.732 T2.
oh, you see, I have to present in a way they can easily understand.
Okay.
You get it back? Their level of mass is not factorized. T2 is common, so I can put T2 outside, then 1 here plus 1.732 bracket close is equals to 122.47. Then add what you have is
2
so
point.
I have T2 into 2.732 is equals to 122.47.
Okay.
So T2 now will be 122.47 over 2.732.
Okay. The answer is 44.83.
83 Newton. So that's T2.
Okay.
Then substitute Substitute for T2 in equation 1. Substitute for T2 in equation 1. So if I do that, I have T1 is equals to 0.7071 over 0.866 T2 into T2. So I calculate this one, and now I've gotten my T2. So it means that T1 is equals to 0.7071 over 0.866 times T2. And what is T2? 44.83 over 1. You know?
The answer is 36.60.
T1.
Yes.
T1 is equals to 36.60
Newton.
Newton.
Yes.
So these are the tensions. I can now conclude this side.
Yes.
So, hence, the tensions in the two strings are 36.60
Newton
and
44.83 Newton. 83 Newton.
Newton. These are my answers.